In this video, we will be discussing on the West African Senior School Certificate Examination, May, June 2006, Chemistry Paper 2. We are starting with Part A, Objective Tests. Before we continue, I want to apologize for the poor quality of the paper that was provided to us. However, if you haven't subscribed to our channel, please like this video, share to other learners, and most importantly, take some time and subscribe to our channel so that other subsequent papers that we are going to be solving will come to you. Thank you very much for taking your time to subscribe to our channel. Let's get started. Answer all the questions. Each question is followed by 4 options, lettered A to D. Find out the correct option for each question and shade in pencil on your answer sheet. The answer space, which bears the same letter, and the option you have chosen, give only one answer to each question. An example is given below. Which of the following elements react with water? A. Carbon, B. Iodine, C. Sodium, and D. Sulfur. The correct answer is sodium, which is lettered C, and therefore answer space C will be shaded. You see how the thing has been shaded. So you have to follow this example here in shading your answer. Think carefully before you shade the answer spaces. Erase completely any answer you wish to change. Do all rough work on this question paper. Now answer the following question. 1. How many orbitals are in the D subshell? The number of orbitals in the D subshell, we have 1, we have 3, we have 5, and we have 7. Just for a minute, for the purpose of revision, please. The D orbital, this is an example. Look for example, this one here. You have, for example, this is the S orbital. The P orbital, for instance, this is the P orbital. For the purpose of revision. This is the P orbital. There are suborbitals in the P. In the P orbital, there are subshells. There we have X, we have Y, we have Z with electron, and it has electron. Each orbital has a maximum of 2 electrons spinning in opposite direction. So therefore, the P orbital, that is Px. Therefore, the P orbital has a total of 6 electrons. The D orbital, again, this is the D orbital. The D orbital, this is the D orbital. The D orbital has 1, that is electrons spinning in opposite direction. So it has a total of 10 electrons. The D orbital has 1, 2, 3, 4, 5 d subshells. So it has a total of what? From our question, how many orbitals are in the d subshell? Okay. An orbital has a maximum of 2 electrons. Then in the d subshell, the d subshell is supposed to have what? It's supposed to have 5 different electrons, meaning the d orbital is supposed to have 5 different subshells, as I've just explained here. One, this is the first one, the second one, the third one, the fourth one, and the fifth one. And each of them has a maximum of 2 electrons, making a total of 10 electrons. So all elements within the D block, they are supposed to have the D block. They are supposed to have a maximum of 10 electrons if they were to complete their orbitals. So we have our answer here is C. We need to shed C. There are 5 orbitals there. 5 orbitals in the D subshell. So we need to have 5. C is our answer. And question number 2. An element has isotopic masses of 6 and 7. These are the masses of the isotopes. If the relative abundance is 1 to 2 respectively, that is the isotope of isotopic mass of 6 has a relative abundance of 1, and the one for 7 has a relative abundance of 12.5. What is the relative atomic mass of X? The relative atomic mass of X. As we said the other time, we said that the isotopic mass times the relative atomic mass divided by the sum of the sum of the relative abundance. So now the isotopic mass, the isotope with the isotopic mass 6 times their abundance is 1, that is 6 times 1, plus the isotope with the relative with the mass of 7 times the relative abundance of 12.5 divided by the sum of their relative abundance. The relative abundance is what? It is 1 plus 12.5. So when we multiply all this, the total sum of the product, that's the product of their isotopic masses times their relative abundance, the total sum will be 93.5. Then the sum of the relative abundance of the different isotopes will be 13.5. When we do that and we add 93.5 divided by 13.5, we will have 6.93. And 6.93 will be our relative atomic mass. 6.93. 6.93 is equivalent to 6 point into 2 decimal places, 1 decimal place. In a 1 decimal place, we'll have 6.9. So our answer is C. An atom X decay by alpha particle. You know what is an alpha particle? An alpha particle is like a helium particle. Helium is 4 and 2. Alpha particle is like a helium particle, which is like alpha particle is like He. An alpha particle is like He, as you might see it like this. Let me say. An alpha particle is like this. Helium is 4 and 2. So this is equal to an alpha particle. An alpha particle has the same, which is 4 and 2. So all these are the same. So we are saying that an atom decays by alpha particle emission to give an atom Y. the atomic number and mass number of Y are. Okay, if we do this, if this undergoes by this decay, this or this, so now we would say this is this decaying by this, the mass number is going to change by 4. So 238 minus 4, which is the alpha particle, will have 234. I mean 238 minus 4 will have 234. Then 92 is going to change, the proton number is going to change by 2. So 92 minus 2, we will have 90. So our particle that is going to be left, the particle that is going to be left would be this. This will be our product after undergoing alpha particle emission. So this is the particle. We will have 2, 3, 4, 90, 90. And let's see if we can have our answer there. So they say the atomic number and the mass number of Y are, the mass number is 234. 234, yes, that is A. And the proton number or the atomic number is 90. So our answer for this is A. So we will need to shed A. Question number 3 is A. Question number 3 is A. So now, after undergoing this, we'll go now to the fourth question. The fourth question says, an element with mass number 133 and atomic number 55 has how many? Has A, 55 electrons. It has 55 electrons and 55 neutrons. Is that possible? Remember that for the purpose of revision, I told you last time that the proton number is equal to the atomic number. The proton number is equal to atomic number, which is also equal to the number of electrons. So if he has I said the proton number is equal to the atomic number, which is also equal to the number of electrons. Then again, the proton number plus the number of neutrons will give us the mass number, or the atomic number plus the number of neutrons will give us the mass number. So now, the number of electrons are supposed to be 55 because atomic number is equal to the number of electrons. Okay, now, to have the number of neutrons, it would be what? It would be 133 minus the proton number, which is 55. And that would be what? And that would be 155 minus, 133 minus 55. We will be having 78 neutrons. We'll be having 78 neutrons. So we will have 55 electrons and 78 neutrons. So the answer for 4 is B. Question number 5. Which of the following pairs of species contain the same number of electrons? Pairs of species. Okay, now, the same number of electrons. 1, you remember that contain the same number of electrons. Now, magnesium has atomic number of 12. Atomic number of 12 is equal to the number of electrons. But the magnesium ion has what? It shows that magnesium 2 plus shows that 2 electrons have been lost. So magnesium now has only 10 electrons. Let's go to aluminum. Aluminum has 13 electrons. Aluminum has 13 electrons. And the ion shows that 3 electrons have been lost. So aluminum now has how many electrons? It has 10 electrons. So just from here, from the first case, from the first case, the answer for 5 is A. The answer for 5 is A. Question number 6. The element X has electronic configuration 1s2, 2s2, 2p6, 3s2, 3p6, and 4s2. Correct. To which group of the periodic table does S belong? It should be remembered. It should be remembered that the last electron is in the s orbital. All s orbitals are metals. The all s blocks, all elements where the last electron is ending in the s orbital, they belong to the s block, and all of the s block is what we call metals, group 1 and group 2. So now, to know the group of the periodic table that this one belong, this is the first shell, which is 2 electrons. Okay, this is the first shell, which is 2 electrons. Then this 2s2, 2s2, 2p6. This is the second shell with 8 electrons. That's right. Then this is the third shell. This is the third shell, or the third energy level, which is 8 electrons. So the last electron in the outermost shell is in the is in the s orbital, and there are 2 electrons there. Therefore, it belongs to group 2 of the periodic table. So in that case, we say it is a metal because it's s block, and with 2 electrons, it shows that group 2 contains electrons, contains metals that have 2 electrons in the outermost shell. So it now belongs to group 2. And our answer for 6 is B. Our answer for 6 is B. Let's go to group, question number 7. Question number 7. Which of the following sets of elements is arranged in order of increasing first ionization energy? First ionization energy is arranged. Which of the following set of elements is arranged in order of increasing first ionization energy? So that is the ionization energy increases. Okay, sodium and lithium. Which one is easy to remove the first what is first of all ionization, the first ionization energy? The first ionization energy is the energy needed or required to remove 1 mole of electron, to remove 1 mole of electron from 1 mole of gaseous ion to form 1 mole of gaseous atom, to form 1 mole of gaseous ion with a unipositive charge. Once more, the first ionization energy is the energy required to remove 1 mole of electron from 1 mole of gaseous atom, please, to form now 1 mole of gaseous ion with a unipositive charge. So now, for these are all metals. As you go down the group, what happens? For group 1, these are all group 1 metals. As you go down the group, for group 1 metals, the ionization energy, the first ionization energy does what? It decreases. The first ionization energy decreases because as you go down the group, the distance from the nucleus and the outermost electrons are increasing because of increasing number of shells. As the distance from the nucleus to the outermost electron is increasing, the force of attraction between the nucleus and the outermost electron is also decreasing, and less energy is required to remove the first electron. So in that case, the first ionization energy as you go down the group is decreasing. So now here it is mixed up. D1 is low, D1 is high, D1 is low, D1 is low. So it's mixed up. D1 is very low, D1 now it is increasing, 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 and this is low again. Now it is D1 is high, this one is down, D1 is up, D1 is down again. No. Now this one is down. As we are moving up the group, is increasing, is increasing, is increasing. So we are told which of the following set of elements is arranged in order of increasing first ionization energy. Our answer is D. I gave you the reason. As you go down the group, there is an increase in the number of shells. The distance from the outermost electron to the nucleus is increasing. The force of attraction between the nucleus and the outermost electron is also increasing. The force of attraction between the outermost electron and the nucleus is decreasing. Therefore, it is easier to remove electron from those down the group than up. So D is our answer. Number 7 is D. Number 8. Number 8. Which of the following electronic configuration represent that of a noble gas? A noble gas is full. Is full. From just observation, it's just a C. It is C. It's very simple. It's always full. So C is the right answer. Okay, let's go to question number 9. Diamond is a hard substance. Diamond is a hard substance because its carbon atoms are held by what? The carbon atom of diamond, the carbon atoms of diamond are held by the localized electron. No. They are held by strong electrostatic forces. No, that exists between ions. C. They are held by van der Waals forces. No, this one will exist but in graphite. D. They are held by strong directional covalent bond. Excellent. That is what happens in diamond. So 9 is D. Question number 10. The presence of unpaired electrons in an atom of a D block element accounts for its ductility. No. Ductility, no. B. Luster, no. Unpaired electron in the D block element. No. C. Malleability. No. D. Paramagnetic. Excellent. Unpaired electron, that is what gives rise to, that's what makes them to be paramagnetic. So 10 is D. The answer for 10 is D. Question number 11. The elements which belong to the same group in the periodic table are characterized by elements belonging to the same group in the periodic table are characterized by A. Difference of plus 1 in the oxidation number of successful members is not appropriate. B. Presence of the same number of outermost electrons in the respective atom. Excellent. That is just all. That is just all. Elements, remember, as we solved in some previous questions, I told you in the periodic table that elements belonging to the same group of the periodic table, they have the same electrons in the outermost shell. For instance, group 1 elements all group 1 elements will have 1 electron in their outermost shell. The same thing, all group 2 elements will have the same will have 2 electrons in their outermost shell. Their number of shells will differ as you go down the group, because as you go down the group, they increase by 1 shell. Those of period 1 will have 1 shell, period 2 will have 2 shells, period 3 will have 3 shells, period 4 will have 4 shells. As they are going down the group, there's a difference in the number of shells by 1. But for the number of electrons, all of them have the same electron in their outermost shell. So our answer for 11 is B. Question number 12. The atomic number of element X and Y are 20 and 17 respectively. Which of the following compounds is likely to be formed by the combination of the 2 electrons? A combination of the 2 electrons. Remember, the atomic number is X of X and Y. X and Y shows that 20 belongs to what? 20 is 2, 8, 8, 2, 8, 8, that is 18, and there are 2 electrons in the outermost shell. So this one has a charge of +2. The one with 20 has a charge of +2. That is, X has a charge of +2. Now, the one with Y is 17. 17 has 2, 8, 7. This one has a charge of -1. This one has a charge of -1. So Y has a charge of -1, and the X has a charge of +2. The compound formed between the X, the 2 of them will be, let's say, we swap their charges. We swap their charges. One for Y will come to X, and the 2 for X will go to Y. So it will be XY2. XY2. So our answer for 12, for question number 12, our answer for question number 12, XY2 is B. Our answer for question number 12 is B. The next one is question number 13. Question number 13 is going to deal with, it has to do with bonding. It has to do with bonding. Question number 13, it has to do with bonding. Now, what type of bond will be formed between element P and Q if their electronegativity values are 0.8 and 0.4 respectively? Okay, remember that the difference in electronegativity has a role to play, whether it is a metal or it is an ionic bond, it is a covalent bond, or it is whether it is an ionic bond, whether it's a covalent bond. Okay, now the difference of a difference of 0.4 and below, a difference of 0.4 and below. For a difference of 0.4 and below, you will see that a difference of 0.4 and below, that is, we will have, that is non-polar covalent bonds. With non-polar covalent bonds. Non-polar covalent bonds will have a difference of 1.7 and 1.7. And above, this is ionic. But the difference here is one. The difference here is what? The difference here is 0. This is 0.8 and this is 4. So we said non-polar bonds that are non-polar covalent bonds, they will have a difference of 1.7. So, and above, 1.7 and above, 1.7 and above. So this bond here, the bond that will be formed between P and the Q, the bond that will be formed between P and Q here would be a covalent bond. It will be a covalent bond. So our answer here is A. Now, for question number 14, what type of chemical bonding is involved in the formation of NH4 plus from a molecule of ammonium, from a molecule of ammonia and a proton? It is ammonia. Once more, I told you we apologize once more for the bad quality or the poor quality of the question paper that we received. Okay, so the type of bond, chemical bond that is involved in the formation of ammonium ion from the molecule of ammonia and a proton. Ammonia and a proton. Ammonia and a proton is what is there is. It should be noted that if you look at this molecule here, let me say this. Ammonia, this is ammonium. Ammonia this is the molecule of ammonia. We'll have ammonia like this. Ammonia has 2 electrons here. Let me say 2 electrons. We have a hydrogen here. It has a lone pair, a 2 lone pair of electrons on the nitrogen. And there is a proton here. There is a proton here. The proton, in order to be stable and complete its outer electron, it will need 2 electrons. So these electrons here will go here. The electrons here will go here. So it will attach itself. This one, nitrogen, will donate the 2 electrons to the proton. And this will be the result of it. It will be the result of it. We will have NH plus, NH4 plus. After this one has attached itself here, we have NH4. So now, this is a coordinate bond. What is a coordinate bond or a dative covalent bond? When a lone pair of electron is donated by only 1 atom. When the lone pair of electron when a lone pair of electron comes from only 1 atom. In this case, nitrogen is the one having the lone pair of electron, donating it to the proton or the hydrogen ion to form ammonium ion. So in that case, going back to and that is coordinate bonding. So now our answer for this, our answer for question number 14 would be B, coordinate covalent bond. That is it. It is not covalent bonding, it is coordinate, because the 2 lone pair of electrons are from a single atom. Question number 15. Question number 15 here has to do with question number 15. What is responsible for metallic bonding? What is responsible for metallic bonding? In metallic bonding, you should know what happens in metallic bonding. They are the localized electrons, localized sea of electrons, and this attraction between the localized sea of electrons and the positively charged nucleus of the atom. So, what is now responsible for metallic bonding? A, attraction between the delocalized electron and fixed positive lattice points. Attraction between the localized electron and fixed positive lattice point or cation. Attraction between positive and negative ions. It's not between positive and negative. Sharing of electrons, transfer of electrons. So it is attraction between delocalized electrons and fixed positive lattice points. that is the positively charged, the nucleus of the atom in the sea of the localized electron. So our answer is A. 15 is A. If we go to question number 16 to 18. Question 16 to 18 is very, very complex, as you might see. In this question, we are told use the following portion of the period Use the following portion of the periodic table to answer question 16 to 18. Okay, we are told they are numbered in groups. The whole system, that is group 1, group 2, group 3, group 4, group 5, group 6, group 7, and group 8. Now, these are their groups. That is the portion of the periodic table that we have been given. Now, studying the periodic table, you should see that this is not period 1, of course. This is not period 1 of the periodic table. This is not period 1. If you look at it critically, this is the periodic table. This is the periodic table. Period 1 starts with hydrogen and the helium. In period 1 has only hydrogen and helium. But only helium belongs to a group. Only helium belongs to group 18. I mean group 18 or group 8 or group 0 of the periodic table. But hydrogen does not belong to any group of the periodic table. Hydrogen does not belong to any group of the periodic table. But here, A is belonging to group 1. A is belonging to group 1. So A cannot be hydrogen. And A and B cannot be in period 1. So the only period that is feasible on that portion of the periodic table is period 2. On period 2 of the periodic table, we have lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and neon. Even though these other sections have been omitted, we have only lithium, which is A, and this other one, and the neon, which has been represented. So in period 2 of the periodic table, we have lithium to neon. Lithium to neon. And the lithium, which is A which is represented here as A. Lithium is represented here as A. And neon is represented, and lithium here is on group 1 of the periodic table, and it is period 2. A here is group 1 of the periodic table, and it is period 2. So this is period 2. It's supposed to be period 2. It is supposed to be period 2. Do not ignore what you are seeing. That is what is written on the question paper. That is how we receive the question paper. But listen to what I am telling you. A belongs to group 1 of the periodic table, and this is period 2. We are starting. So this periodic table starts from period 2. This periodic table starts from period 2, period 3, and period 4. Because initially period 1 was here. So period 1, in period 1 we don't have, in period 1 there is no group, is hydrogen, and hydrogen does not belong to any group. So we cannot be saying that this is period 1. So this is period 2, period 3, and period 4. If you want to answer your question very well. So the portion of the periodic table here begins from period 2 to period 4. In period 2, only lithium, which is A, is in group 1. And the neon, which is B, that belongs to group 8, are present. So we have period 2, period 3, and period 4. And we want to answer our questions. So do not be confused. We want to answer our question. So now, which of the letters indicate elements which exist as diatomic gases? The only diatomic gases here, which are the letters, which of the letters? B and G, B and G, they are gases. These are noble gases, but they are not diatomic. They are not diatomic. So we cannot take, we cannot even take A because they are inert gases. Okay, B, B, C and F, C and F. C is a group 2 element and is a metal. So in that case, we rule out that. The only one here is F. F is a group 7 element, and F is, it belongs to what? Period 1, 2, period 3. And if it is period 3, then this is bromine. This is bromine. So this question is C and A. C is a metal, A is a metal. It's not possible. D, A and the E. A and E, all are metals. So in this case, I cannot give an answer to this because the question is not of standard. Okay, let's go to question number 17. Which of the letters represent an alkaline earth metal? An alkaline earth metals are all group 2 metals. So in that case, C is the right answer. And C is what? C is an alkaline earth. Which of these represent an alkaline earth metal is C, and C is group 2. So C is D. So question number 17 is D. So D is right. D is right. Question number 18. Question number 18. Which of the following pairs of letters denote element containing the same number of electrons? Element containing the same number of electrons in their outermost shell. Outermost means above 2 shells. Outermost. Because if it was 2 shells, they would tell you their outer shell. But outermost is above 2 shells. Should be 3 shells and above. Okay. For 3 shells and above, we will have for question 18, we will have the same number of electrons in the outermost shell. C and D, C and D, C and D, no. B, E and F, E and F, no. C, B and G, B and G, B and G, B and G, B and G. B is B is B is neon. B is neon. And the neon has how many electrons? The outermost electron for neon, that is, neon has 2, in that case, neon, 10 electrons, that is 2, 8. Okay, 28, B and G. So they have the same electrons in the outermost shell. Outermost shell, we will have B and G. So we will have C as our answer for that, 18. C for 18 is B and G. C. This C. And number 19. If 1 mole of sodium contains 6 times 10 to the 23rd atoms, how many atoms are contained in 0.6 gram of sodium? How many atoms, if 1 mole of sodium contains that, how many atoms will that contain? Okay, 0.6 gram of sodium. Okay, let's look the calculations. 1 mole is equals to 6.0 10 to the 23rd atoms. Then 0.6 gram. 0.6 gram is what? 0.6 gram to have the number of moles of sodium. 0.6 and sodium is 23. 0.6 divided by 23, which is the atomic mass, relative atomic mass of sodium. We will have 0.026. 0.026. Those are the number of moles. We have been given grams here. And to convert it to moles, we divide it by the relative atomic mass is 0.026. So 0.026 will be equal to what? It will contain the number of atoms. 0.026 moles of sodium will contain this number of atoms. I mean, 0.026, which is the number of moles. 1 mole is this. Then 0.06, how many moles? Will be 1.56. How many atoms, sorry? Will be 1.56 times 10 to the 22nd. So 1.56 times 10 to the 22nd will give us what answer is that? Number 19. It will give us B as our answer. So B should be our answer for this. Again, 20. Question number 20. 20 cm cube of distilled water is added to 80 cm cube of 0.50 mole per dm cube hydrochloric acids. The net concentration of the acid will be what? Okay, remember, this is the initial volume, and this is the initial concentration of the acids. When we now dilute it with 20 cm cube, this will be the second volume. We will then dilute it with distilled water of 20 cm cube. That is the second volume. What will now be the second concentration? This is the initial concentration and the initial volume. Then the final volume, and what will be our initial our final concentration. Let's use this expression in solving it. The concentration, concentration 1, we can say concentration of acids, volume of acids, the concentration of the same acid 2, volume of acid 2. So precisely, we are saying C1 V1 equals to C2 V2. Now, initial concentration was 0.5 mole per dm cube, and the initial volume was 80 cm cube. The final volume was 20 cm cube, and the final concentration, that's what we have been asked to calculate, the net concentration. Making C2 the subject from this equation, we can now say it is C1 V1 divided by V2, and our C2 will be 0.5 mole per dm cube times the volume, which is cm cube, divided by the volume, which is cm cube. And the volume and volume will cancel. We are now looking for a dm cube, which will be 40 divided by 20. We will have 2.00 mole per dm cube. If we go to our answer column, we will have D as our answer. Question 20 is D. And 21, consider the reaction represented by the equation this. 2 NaHCO3 heat Na2CO3 plus this plus that. What volume of carbon dioxide? What volume of carbon dioxide or carbon 4 oxide at standard temperature and pressure is evolved when 0.5 moles of sodium hydrogen carbonate is heated? Remember, the molar volume, that is the molar volume for 1 mole of a gas at standard temperature and pressure is 22.4 dm cube. Using our equation, from our equation, you see that 2 moles of this will give 1 mole of carbon dioxide. Okay, from the equation, 2 moles of sodium hydrogen carbonate will give 1 mole of carbon dioxide. Therefore, 0.5 moles of sodium hydrogen carbonate, these are the 5 moles that have been given, will give how many moles of carbon dioxide? Our value of X will be 0.25 moles of carbon dioxide. But remember, at standard temperature and pressure, 1 mole of a gas will occupy 22.4 dm cube. Therefore, the volume occupied by 0.25 moles of carbon dioxide will be what? Will be 22.4 dm cube times 0.25, and we will have 5.6 dm cube. If we go to our answer column, can we have that? 5.6, that is the answer there. Our answer for 21 is C. Question number 22. Which of the following gases will have the lowest rate of diffusion under the same condition? We have nitrogen, oxygen, chlorine, and their argon. Which of them will have the lowest rate of diffusion? Okay, taking into consideration some of our postulates, according to Graham's law of effusion. According to Graham's law of effusion, lighter gases would diffuse faster than heavier gases. Some of these lighter gases would diffuse faster than the heavier one. And how do you think we will know which one is heavier, which gas is heavier than the other one? We can only know it from their relative atomic masses, that is, from their molecular weight. Okay, for instance, argon is 40. It has a molecular weight of 40. Chlorine is diatomic, so it's 35.5 times 2, which is 71. Nitrogen is diatomic, so it's 14 times 2, which is 28. Oxygen is diatomic, which is 16 times 2, which is 32. If we compare the molecular weights of all these gases, you will see that chlorine is the most heavier one. So this one has the highest mass, more than any other gas, and for that reason we will say chlorine will diffuse. The chlorine will have the lowest rate of diffusion because of its high molecular weight. So let's look at our gases and see. From the gases, obviously B will be our answer because B has the highest mass. So chlorine has the highest mass. Okay, let's go to 23. 23 is consider this Consider the reaction hydrogen ion aqueous, that it is in solution, plus OH ion aqueous, that is still in solution, to give a molecule or 1 mole of water. To give 1 mole of water. The energy change taking place in the reaction above is enthalpy of what? Is it enthalpy of formation? Yes, you may look at it as enthalpy of formation, but enthalpy of formation is not in aqueous solution like that. Is it enthalpy of hydration? Yeah, it's not enthalpy of hydration, because it involves, here it is involving an acid and an alkali, acid and base, an acid and a base. That is a proton and an OH reacting to form a molecule of water. When a proton get mixed up with an OH ion, a hydroxide ion, what is that? That is what we call neutralization. That is when an acid is reacting with a base or an alkali of this nature, there's neutralization that is taking place. And what is the heat of neutralization? The enthalpy change of neutralization will result in what? It result in the formation of 1 mole of water, and there's 1 mole of water here. So the enthalpy of formation here, the enthalpy here, the enthalpy of the reaction. The enthalpy of the reaction is enthalpy of neutralization. So C is our right answer. It's enthalpy of neutralization. It's not formation, it's not hydration, it's not solution. Which of the following processes is an endothermic reaction? Endothermic. Endothermic is when heat is absorbed from the surrounding, and in endothermic reaction, bonds are being broken. Bonds are being broken. But in exothermic reaction, heat is released to the surrounding. And during exothermic reaction, bonds are being formed. So now, which of the following processes is an endothermic? Let's see this one. Dissolving NH4. Dissolving NH4. Dissolving NH4. That is ammonium chloride crystal in water. I said in endothermic reaction, heat is absorbed from the surrounding, and that heat is used in the breaking of bonds. So energy is required for bond breaking. So in endothermic reaction, bonds are being broken. So when we dissolve this in solution, what is going to happen? When we dissolve this in solution, we are going to have NH4 plus Cl minus. In this case, bonds have been broken. The bonds have been broken. The crystals bonds have been broken. Energy have been absorbed in breaking this bond. So A is a possible answer. Let's go to B. Addition of concentrated sulfuric acid to water. In the laboratory, when you take concentrated sulfuric acid in a glass beaker, glass beaker, you put some water there. You put concentrated sulfuric acid, and then you put some concentrated sulfuric acid on it. What happens? What is noticed is that there is going to be generation of heat. Concentrated sulfuric acid is a strong acid that will generate heat, and when added to water, heat is being generated. If you touch the walls of the glass beaker, you will notice that heat has been lost to the surrounding. That's why it is hot. And in a reaction where heat is being released, to the surrounding. We call that exothermic reaction. So B is out of question. C, dissolving sodium hydroxide pellets in water. Sodium hydroxide pellets, they are just like tablets as you see them. When you put them in a beaker of water, you want to make a solution. Maybe you want to make a standard solution of sodium hydroxide. When you put it in maybe in a volumetric flask, you want to dissolve it. What you will notice will be, as the sodium hydroxide pellets are dissolving, the heat is being released, and you will notice that heat is being released. If you don't have a thermometer to measure it, you will notice it by feeling it on the walls of the volumetric flask. You will notice that the walls of the volumetric flask or the glass beaker are hot, indicating that heat has been released in trying to dissolve sodium pellets in water. So where heat is being released, it is an exothermic reaction. So C is out of question. D, passing sulfur trioxide gas into water. When we pass sulfur trioxide gas into water, heat is also generated. Heat is also generated. It's the same thing that is happening in the air when the formation of acidic rain, when the sulfur dioxide now reacts with air in the atmosphere, sulfur trioxide is formed, and when it gets mixed up in the air with water, acidic rain, we call it sulfurous acid. Sulfurous acid is being formed. So in that case, heat is being released in this case. So D is out of question. The only one that is an endothermic reaction that will result in the breaking of bonds will be A. So our answer for 24 is A. Alternatively, if you can't understand this explanation, another method is separation of ions to separate ions. Separation of ions will require endothermic. It's an endothermic reaction. And during endothermic reaction, more energy is required. Then hydration of ions. In hydrating ions, exothermic hydration of ion is an exothermic process. That is, energy is being energy is being released, and only less energy is released. And more energy in the endothermic process and the less energy in the exothermic process, the total sum, the total difference between the two is endothermic. That's another way you can understand the first one I explained. Number 25, a reaction pathway. In the energy profile diagram below, which letter represent the activation energy for the reverse reaction? It is not was as a result of photocopy. The last letters were not did not come out clearly. So, which letter represent the activation energy for the reverse reaction? If you look at this reaction, the reaction pathway here shows that this is an endothermic reaction. This is an endothermic reaction. And the reverse, that is reactant to product. It leads from here to the activated. This is activated complex. From the activated complex, we come down where the products are formed. And from here to here, that's what we call the activation energy, EA. I mean, from here, that's activation energy. So now, for the reverse reaction, the products here are going to be the reactants, and the reactants here will be the product. The reverse reaction now is, the reaction is going to start but from the right to the left. So this will be our reactant and this will be our product. In that case, the reaction will lead from here right to the activated complex, and now where the bonds are being formed. Now from here to this summit here will be our activation energy. This will be our activation energy for the reverse reaction. But for the forward reaction, that is from left to right, our activation energy is X. For reverse, it is Y, because this is the reactant and this will be the product. So the forward reaction is endothermic, and the backward reaction, or the reverse reaction, is exothermic. So now the question says, which letter represent the activation energy for the reverse reaction? The letter that represent the activation energy for the reverse reaction is Y, and our answer here is, our answer is B. Our answer is B. Y is the activation energy for the reverse reaction. Okay, 26. Question 26. Which of the following aqueous solution turns red litmus to blue? Red litmus to blue. In solution. Aqueous solution. That is, if this is dissolved in water and then you put a red litmus paper there, it turns the red litmus paper to blue. Which of this? In solution, this will not do that. In solution, sodium ethanoate will not do that. In solution, aluminum chloride will not do that. What will only do, the only aqueous solution that will do it will be ammonium chloride. Because when ammonium chloride dissolves in water, from our last question, you saw that, from our last question, you will see that this ammonium chloride is formed as a result of ammonia reacting with hydrogen chloride. Ammonia reacting with hydrogen chloride. So when ammonia reacts with hydrogen chloride, what will be the when ammonia reacts with hydrogen chloride? When ammonia reacts with hydrogen chloride, we will form ammonium chloride. So in this case, it is the ammonia. It is the ammonia that is going to work here. So the ammonia here will be the one. This will let me excuse me. In solution, these are the ions. In solution, these are the ions that are going to be formed in solution. But practically, you will see that it is this if it is not in solution, you will have this. When this reacts, is going to give this. When this reacts, this is going to give this one here. So the ammonium, this equation is in solution. So in the ammonium, only ammonia gas, which is also used as a test, a chemical test for ammonia, will do what? Will turn red litmus paper blue. So it is only the ammonia present here that will turn the red litmus paper blue. So in that case, we are saying that In that case, we are saying that only this compound will do that in solution. D. 27. Which of the following methods cannot be used to distinguish between a strong acid and a weak acid and a weak acid? A strong acid and a weak acid. Conductivity? No. Measurement of pH? No. C. Measurement of heat of neutralization? Heat of neutralization? No. Action on starch? Action on starch? Iodide paper. Action on starch, iodide paper. Yeah. So we will have 27 D as our paper, as our answer for this. You have 28. The indicator used in neutralizing ethanoic acid and sodium hydroxide solution has a pH of. This is an acid, weak acid, and a weak acid and a strong base. A weak acid and a strong base. That is the alkali there. Sodium hydroxide alkali. That is weak acid and a strong alkali. Weak acid and a strong alkali. A weak acid and a strong alkali. We will have phenolphthalein indicator. Phenolphthalein indicator is the one that is being used. And for phenolphthalein indicator, to have phenolphthalein indicator will be for strong acid, weak acid, and weak and strong alkali. A phenolphthalein indicator is between the pH for phenolphthalein indicator is 8.2 to 10. Is 8.2 to 10. So 8.2 to 10 will be for the phenolphthalein indicator. And the resultant in that type of reaction, sodium hydroxide and that is a weak acid here, and a strong base. This is a strong base. A weak acid here. The weak acid is between this region 4, 3, and a strong base and a strong alkali. So it will result in pink. The end point will be pink, and phenolphthalein will be what? 8.2 to 10. That's the pH. 8.2 to 10 to pH. 8.2 to 10. That is our answer for this is C. 8.2 to 10. That is, we are most detailed. 8 to 10. Yeah. 29. When aqueous ammonia is added to one of the following solutions, a white precipitate which dissolves in excess ammonia is formed. Identify the solution. If you have done tests for cations, you will realize that for tests for cations, you will realize that tests for cations, you will realize that only when aqueous ammonia is added to zinc chloride. When aqueous ammonia is added to zinc chloride, a zinc ion is formed up and is observed as white precipitate. And when excess of aqueous ammonia is added to the white precipitate, it dissolves. It dissolves in excess. So our answer here will be zinc chloride. Go to your qualitative analysis. You will see it there. Test for cations. Okay. Now, question number 30. When 30 is when 50 cm cube of a saturated solution of a potassium nitrate at 25 degrees Celsius was evaporated to dryness, 10 grams of dry salt was obtained. What is the solubility of a potassium nitrate at 25 degrees Celsius? The solubility here, the solubility here in mole per dm cube, we are calling the solubility in mole per dm cube. That's the concentration. What is the solubility? Or in other words, what is the concentration? What is the solubility? In other words, what is the concentration? To have the concentration, the first thing we do is, since we're given 10 grams of the dry salt was recovered, so what was, we were given the molar mass of potassium nitrate to be 101. So the number of moles for this, the number of moles for the dry salt that was recovered will be 10 grams divided by the molar mass, which is 0.099 moles. Now, the volume we were given, what was the volume of the saturated solution? The volume of the saturated solution was 50 cm cube, and 50 cm cube. The volume in dm cube will what? 50 cm cube divided by 1000 cm cube, we will have 0.05 dm cube. Then we have an expression which is concentration is equal to mole divided by volume in dm cube. To have our concentration in mole per dm cube, which is the solubility we are looking for, we will have 0.099 mole divided by 0.05 dm cube. Our final, we will have 1.98, which is approximately 2.00 mole per dm cube. And if we go to our answer column, our answer will be B for 30. Our answer will be B for 30 for the solubility. Now, which of the following compound absorb moisture from the atmosphere and dissolves in it? It absorbs moisture from the atmosphere and dissolves in it. That is a compound that is hygroscopic, or that salt should be hygroscopic or a deliquescent salt. A deliquescent salt. That type of salt, that is mostly iron 3 chloride. It's mostly iron 3 chloride that does that. So our answer is A. Now, we will go to 32. Question number 32. Consider the diagram below. Of course, this shows a diagram of a titration. The setup is used for the preparation of a salt. Maybe preparation of salt by titration. Okay. Preparation of a salt by A. Double decomposition. B. Crystallization. C. Neutralization. And D. Direct combination. Direct combination. Here, this is an acid base titration. What we call acid base titration. This is dilute acid, let me say hydrochloric acid. And this is sodium hydroxide solution. When you add dilute acid, let me say sodium chloride, to this, what will be formed would be what will result in this reaction here would be, we will have, just an example for the dilute acid. Let me say sodium chloride, dilute acid, which is hydrochloric acid, HCl, which is aqueous, plus sodium hydroxide, NaOH, yeah, And the resultant here will be what? This is an acid alkali or acid-base titration. We will have sodium chloride, plus 1 mole of water. Formation of 1 mole of water indicates neutralization. This is salt. This is salt. The sodium chloride that is being formed, we will not take it. This is sodium chloride, this is salt. We will not take it after titrating it and get it to the end point. We will not collect this in our, or let me say, in our conical flask. We will not collect it in our conical flask. When we in our conical flask, we can transfer it now into what we call in a glass beaker. We heat it. This is the glass rod. We heat it to a level where there is crystals. We start seeing crystals on the walls of our glass rod. So when we heat it, water will escape. Most of the water will escape, and we will notice that we have heated it to a level of saturation when there are some crystals on the glass rod. We're now transferring now into what we call our and do the heating there finally. And do the heating there. We now try it to our evaporating dish. In our evaporating dish, what will happen there? We will evaporate it until when the crystals are formed, we now take them, wash them with some little distilled or deionized water, and put them in a low oven until the crystals are formed. That is crystallization. So now, back to our question. We were saying salt is being formed, and the process of a dilute acid reacting with an alkali to form salt and a mole of water is what we call neutralization. So our method here, the answer here is neutralization. So our right answer here is neutralization. C is the right answer for 32. Let's go to question number 33. Question number 33 has to do with equilibrium. Consider the equation for the equilibrium reaction. We have ammonia and hydrogen to form in an equilibrium condition to form 2 moles of ammonia. All are gaseous reaction. And this is the enthalpy change is exothermic, minus 92 kilojoule per mole. The equilibrium constant for the reaction can be expressed as follows. The only way to express the equilibrium constant here is the way you can express the equilibrium constant is the way you can for the reaction equilibrium constant Kc. Kc, if you were to look for Kc, the Kc is what? From this, we'll call it Kc is the product raised to the power of its coefficient. The product if it is 1, raised to the power of its coefficient. The product raised to the power of its coefficient. And what was its coefficient here? It is 2. The product is ammonia. Let me just put it there. Okay. The product was ammonium. So Kc is ammonium. So the product is ammonium raised to the power of its coefficient. What was the coefficient here? The equation is 2. Divided by the product of the reactants. Product of the reactants. What are the reactants? The reactants are the product of the concentration of the reactants. So the concentration of the reactants. What are the reactants? You have hydrogen, and nitrogen. The product of the concentration of the reactants raised to the power of their coefficients. Product means, a product means this times this. We are multiplying them. The products. So the product of the reactants, that is raised to the power of their coefficient. So this is the for ammonia, for nitrogen, the coefficient is 1. Then we are saying the product, that is times hydrogen raised to the power of their coefficient. The coefficient for hydrogen here is what? Is 3. So that is how it is supposed to be. Once more, the equilibrium constant for this reaction is the concentration of the product raised to the power of its coefficient. This is the concentration of the product. This is the coefficient divided by the product of the reactants. The product, that is multiplication of the product and multiplication of the reactants raised to the power of their coefficient. And the product, the concentration of nitrogen is this one. The power of the coefficient is just 1. It remains hydrogen, and the power, the coefficient of nitrogen in the reaction is 3. So if we look at this, and we come back to our equation here and see which one corresponds to this reaction, we will say D is the right answer. D is the right answer for no, it's not D. It's not D. It's not D. Which one is the right answer for this one? The right answer for this 3, yeah, and B. So we will now say the right answer is B. So ammonia to 2, nitrogen and hydrogen to 3. So our right answer is B. Let's put it there. Our right answer is B. 43 is B. So that is how you can do it. That is the only way you can do that. That is the only way you can do that. Okay, let's continue. Let's go ahead with our question. Okay, for 33, we have our right answer. We say it is B. 34, which might be the last question. Consider the reaction represented by the equation. We have sulfur dioxide plus oxygen to give in equilibrium to give sulfur trioxide. The reaction, they are all gaseous reaction, and the enthalpy change is negative 197 kilojoule per mole. This is an exothermic reaction. Okay, which of the following conditions will not increase the yield of sulfur 6 oxide? This is sulfur 6 oxide. Which of the following conditions will not increase the yield of sulfur trioxide or sulfur 6 oxide? Okay, let's see how we can do it. With A, this is remember, you must know the condition. This is an exothermic reaction. It is an exothermic reaction. So now, increase will not. So increase in temperature. Increasing the temperature, being an exothermic reaction, increasing the temperature will favor, but what? It will favor but the endothermic direction. Since this is an exothermic reaction, if we now increase the temperature, It will now increase the temperature. It will favor but an exothermic, an endothermic direction. That is, instead of the formation of SO3, SO3 is going, because temperature has increased, is going to break down into formation of more SO2 and O2. So the reaction is going to shift but to the left. And this also applies according to the equilibrium is going to shift but to the left. So A is likely going to be the answer. B, decrease in temperature. Decreasing the temperature, since it is an exothermic reaction, exothermic reaction will favor low temperatures. At low temperatures, more of the product is being formed. So at low temperature, or when the temperature is decreased, more of the SO3 or sulfur trioxide or sulfur 6 oxide are going to be formed. So no, this one will not. This one will increase the production of SO3. So it's not accepted. B is not accepted. C, increase in pressure. According to increase in pressure, increasing the pressure, according to Le Chatelier's principle, increasing the pressure of this reaction, what happens? Le Chatelier's principle states that if a system in equilibrium is subjected to a change, the equilibrium or the system must react in such a way to oppose the change and restore the equilibrium. So now if the pressure is being increased here, what happens? There are 2 moles on the right hand side, and there are 3 moles. So if the equilibrium will shift but to the area of low or less number of moles. So the equilibrium is going to shift but to the right. So therefore increasing SO3 production. So no. D, addition of oxygen into the mixture. If we add oxygen here, we are increasing the number of reactants, which is subsequently going to increase the number of reactants, and definitely going to increase the production of SO3. But when we increase the temperature, the equilibrium is going to shift but to the left. It is going to, when we increase temperature, we are instead favoring but endothermic direction. That is equilibrium shifting to the left. That is production of more sulfur dioxide and oxygen. So A is the only condition that will not increase the yield of sulfur 6 oxide or sulfur trioxide. So our answer for this question is A. So question number, okay, that's all. Thank you, fellow learners, for being patient and listening to the discussion. Once more, I apologize for the poor quality of the question paper we received. However, if you haven't subscribed to our channel, please like this video, share to other learners, and most importantly, take some time and subscribe to our channel so that other papers that we are going to be solving, you'll be having them. Thank you for listening.